Data mining. Definition: data mining is defined as the procedure of extracting information from huge sets of data. In other words, data mining is mining knowledge from data. Terminologies involved in data mining: knowledge discovery, query language, classification and prediction, decision tree induction, cluster analysis, etc. There is a huge amount of data available in the information industry. This data is of no use until it is converted into useful information. It is necessary to analyze this huge amount of data and extract useful information from it. Extraction of information is not the only process we need to perform. Data mining also involves other processes such as data cleaning, data integration, data transformation, data mining, pattern evaluation and data presentation. The information or knowledge extracted can be used for any of the following applications: market analysis, fraud detection, customer retention, production control, science exploration, data warehousing. A data warehouse, or enterprise data warehouse, EDW, is a system that aggregates data from different sources into a single, central, consistent data store to support data analysis, data mining, artificial intelligence, AI, and machine learning. Data warehousing is the process of constructing and using a data warehouse. A data warehouse is constructed by integrating data from multiple heterogeneous sources that support analytical reporting, structured and/or ad hoc queries, and decision-making. Data warehousing involves data cleaning, data integration, and data consolidations. Using data warehouse information. There are decision support technologies that help utilize the data available in a data warehouse. These technologies help executives to use the warehouse quickly and effectively. They can gather data, analyze it, and take decisions based on the information present in the warehouse. The information gathered in a warehouse can be used in any of the following domains. Tuning production strategies. The product strategies can be well tuned by repositioning the products and managing the product portfolios by comparing the sales quarterly or yearly. Customer analysis. Customer analysis is done by analyzing the customer's buying preferences, buying time, budget cycles, etc. Operations analysis. Data warehousing also helps in customer relationship management and making environmental corrections. The information also allows us to analyze business operations. Functions of data warehouse: tools and utilities. Data extraction involves gathering data from multiple heterogeneous sources. Data cleaning involves finding and correcting the errors in data. Data transformation involves converting the data from legacy format to warehouse format. Data loading involves sorting, summarizing, consolidating, checking integrity, and building indices and partitions. Refreshing involves updating from data sources to warehouse. ETL. ETL stands for extract, transform, and load. It is defined as a data integration service and allows companies to combine data from various sources into a single, consistent data store that is loaded into a data warehouse or any other target system. Steps involved in the ETL process. Extraction. In this, the structured or unstructured data is extracted from its source and consolidated into a single repository. ETL tools automate the extraction process and create a more efficient and reliable workflow for handling large volumes of data and multiple sources. Transformation. In order to improve data integrity, the data needs to be transformed, such as it needs to be sorted, standardized, and redundant data should be removed. This step ensures that raw data which arrives at its new destination is fully compatible and ready to use. Loading. This is the final step of the ETL process, which involves loading the data into the final destination, data lake or data warehouse. The data can be loaded all at once, full load, or at scheduled intervals, incremental load. ETL tools are applications/platforms that enable users to execute ETL processes. In simple terms, these tools help businesses move data from one or many disparate data sources to a destination. These help in making the data both digestible and accessible, and in turn analysis ready, in the desired location, often a data warehouse. ETL tools are the first essential step in the data warehousing process that eventually make more informed decisions in less time. Types of ETL tools. Enterprise ETL tools. The ETL tools are often bundled as part of a larger platform and appeal to enterprises with older, legacy systems that they need to work with and build on. These ETL tools can handle pipelines efficiently and are highly scalable since they were one of the first to offer ETL tools and mature in the market. These tools support most relational and non-relational databases. Custom ETL tools. In this, the custom tools and pipelines are created using scripting languages like SQL or Python. While this gives you an opportunity for customization and higher flexibility, it also requires more administration and maintenance. Cloud-based ETL tools. These tools integrate with proprietary data sources and ingest data from different web apps or on-premises sources. These tools move data between systems and copy, transform, and enrich data before writing it to data warehouses or data lakes. Open source ETL tools. Many ETL tools today are free and provide easy-to-use user interfaces for designing data exchange processes and monitoring the flow of information. An advantage of open-source solutions is that organizations can access the source code to study the tool infrastructure and extend the functionality. Best ETL tools for 2023. Heva Data Pentahotelend AWS Glue, Azure Data Factory etc. Classification in data mining. Classification in data mining is a common technique that separates data points into different classes. It allows you to organize data sets of all sorts, including complex and large data sets as well as small and simple ones. It primarily involves using algorithms that you can easily modify to improve the data quality. The primary goal of classification is to connect a variable of interest with the required variables. The algorithm establishes the link between the variables for prediction. The algorithm used for classification in data mining is called the classifier, and observations are called the instances. Example: a bank loan officer wants to analyze the data in order to know which customer, loan applicant, are risky or which are safe. The data classification process includes two steps. Building the classifier or model. Using classifier for classification. Building the classifier or model. This step is the learning step or the learning phase. In this step the classification algorithms build the classifier. The classifier is built from the training set made up of database tuples and their associated class labels. A model or classifier is constructed to predict the categorical labels. These labels are risky or safe for loan application data. Using classifier for classification. In this step, the classifier is used for classification. Here the test data is used to estimate the accuracy of classification rules. The classification rules can be applied to the new data tuples if the accuracy is considered acceptable. Prediction. To find a numerical output, prediction is used. The training dataset contains the inputs and numerical output values. According to the training dataset, the algorithm generates a model or predictor. When fresh data is provided, the model should find a numerical output. This approach, unlike classification, does not have a class label. A continuous valued function or ordered value is predicted by the model. Example: 1. Predicting the worth of a home based on facts like the number of rooms, total area, and so on. A marketing manager needs to forecast how much a specific consumer will spend during a sale. In this scenario, we are bothered to forecast a numerical value. In this situation, a model or predictor that forecasts a continuous or ordered value function will be built. Regression in data mining. Regression refers to a data mining technique that is used to predict the numeric values in a given data set. Regression involves the technique of fitting a straight line or a curve on numerous data points. For example, regression might be used to predict the product or service cost or other variables. It is also used in various industries for business and marketing behavior, trend analysis, and financial forecast. Regression is divided into 5 different types. Linear regression, logistic regression, lasso regression, ridge regression, Polynomial regression. The most popular types of regressions are linear and logistic regressions. Linear regression. Linear regression is the type of regression that forms a relationship between the target variable and one or more independent variables utilizing a straight line. The given equation represents the equation of linear regression. It is a statistical method that is used for predictive analysis. Linear regression makes predictions for continuous/real or numeric variables such as sales, salary, age, product price, etc. Linear regression algorithm shows a linear relationship between a dependent, y, and one or more independent, x, variables, hence called as linear regression. The linear regression model provides a sloped straight line representing the relationship between the variables. The values for x and y variables are training data sets, data points, for linear regression model representation. Y equals a plus b asterisk x plus e. Where a represents the intercept of the line, the point where the line or curve crosses the axis of the graph is called intercept. If a point crosses the x-axis, then it is called the x-intercept. If a point crosses the y-axis, then it is called the y-intercept. B represents the slope of the regression line. E represents the random error. X represent the predictor variable, independent. Y represent the target variable, dependent. Applications. Medical researchers can use this regression model to determine the relationship between independent characteristics, such as age and body weight, and dependent ones, such as blood pressure. This can help reveal the risk factors associated with diseases. They can use this information to identify high-risk patients and promote healthy lifestyles. Financial analysts use linear models to evaluate a company's operational performance and forecast returns on investment. They also use it in the capital asset pricing model, which studies the relationship between the expected investment returns and the associated market risks. It shows companies if an investment has a fair price and contributes to decisions on whether or not to invest in the asset. Logistic regression. When the dependent variable is binary in nature, i.e., 0 and 1, true or false, success or failure, the logistic regression technique comes into existence. Here, the target value, y, ranges from 0 to 1, and it is primarily used for classification-based problems. Unlike linear regression, it does not need any independent and dependent variables to have a linear relationship. Example, acceptance into university based on student grades. Logistic regression predicts the output of a categorical dependent variable. Therefore the outcome must be either yes or no, 0 or 1, true or false, etc. In logistic regression, instead of fitting a regression line, we fit an S-shaped logistic function, which predicts two maximum values, 0 or 1. Logistic regression applications in business. 1. An e-commerce company that mails expensive promotional offers to customers, would like to know whether a particular customer is likely to respond to the offers or not, i.e., whether that consumer will be a responder or a non-responder. 2. Likewise, a credit card company will develop a model to help it predict if a customer is going to default on its credit card based on such characteristics as annual income, monthly credit card payments and the number of defaults. 3. A medical researcher may want to know the impact of a new drug on treatment outcomes across different age groups. This involves a lot of nested multiplication and division for comparing the outcomes of young and older people who never received a treatment, younger people who received the treatment, older people who received the treatment, and then the whole spontaneous healing rate of the entire group. 4. Logistic regression has become particularly popular in online advertising, enabling marketers to predict the likelihood of specific website users who will click on particular advertisements as a yes or no percentage. 5. In healthcare to identify risk factors for diseases and plan preventive measures. 6. In drug research to learn the effectiveness of medicines on health outcomes across age, gender etc. 7. In weather forecasting apps to predict snowfall and weather conditions. 8. In political polls to determine if voters will vote for a particular candidate. 9. In banking to predict the chances that a loan applicant will default on a loan or not, based on annual income, past defaults and past debts. Note, the main difference between logistic and linear regression is that logistic regression provides a constant output, while linear regression provides a continuous output. Time series analysis. Time series analysis is a specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at consistent intervals over a set period of time rather than just recording the data points intermittently or randomly. However, this type of analysis is not merely the act of collecting data over time. Time series analysis can show how variables change over time. In other words, time is a crucial variable because it shows how the data adjusts over the course of the data points as well as the final results. It provides an additional source of information and a set order of dependencies between the data. Time series analysis typically requires a large number of data points to ensure consistency and reliability. An extensive data set ensures you have a representative sample size and that analysis can cut through noisy data. Examples: weather forecast, rainfall measurements, temperature readings, heart rate monitoring, ECG, brain monitoring, quarterly sales, stock market analysis, automated stock trading, industry forecasts, interest rates. Time series is also used in several non-financial contexts, such as measuring the change in population over time. The figure below depicts such a time series for the growth of the U.S. population over the century from 1900 to 2000. Dia, a time series graph of the population of the United States from 1900 to 2000. Summarization. The term data summarization can be defined as the presentation of a summary/report of generated data in a comprehensible and informative manner. To relay information about the dataset, summarization is obtained from the entire dataset. It is a carefully performed summary that will convey trends and patterns from the dataset in a simplified manner. Data has become more complex, hence, there is a need to summarize the data to gain useful information. Data summarization has great importance in data mining as it can also help in deciding appropriate statistical tests to use depending on the general trends revealed from the summarization. Areas in which data summarization is implemented: centrality, dispersion, distribution of a sample of data. 1. Centrality. The principle of centrality is used to describe the center or middle value of the data. Measures used to show the centrality. Mean, this is used to calculate the numerical average of the set of values. Mode, this shows the most frequently repeated value in a dataset. Median, this identifies the value in the middle of all the values in the dataset when values are ranked in order. The most appropriate measure to use will depend largely on the shape of the dataset. 2. Dispersion. The dispersion of a sample refers to spreading out the values around the average, center. It shows the amount of variation or diversity within the data. When the values are close to the center, the sample has low dispersion while high dispersion occurs when they are widely scattered about the center. Different measures of dispersion can be used based on the dataset. 1. Standard deviation. This provides a standard way of knowing what is normal or extra large or extra small and helps to understand the spread of the variable from the mean. It shows how close all the values are to the mean. Variance. This is similar to standard deviation but it measures how tightly or loosely values are spread around the average. 3. Range. The range indicates the difference between the largest and the smallest values, thereby showing the distance between the extremes. 3. Distribution of a sample of data. The distribution of sample data values has to do with the shape, which refers to how data values are distributed across the range of values in the sample. In simple terms, it means if the values are clustered around the average to show how they are symmetrically arranged around it, or if there are more values to one side than the order. 2 ways to explore the distribution of the sample data are: graphically, through shape statistics. Clustering. Clustering is the method of converting a group of abstract objects into classes of similar objects. Clustering is a method of partitioning a set of data or objects into a set of significant subclasses called clusters. It helps users to understand the structure or natural grouping in a data set and used either as a standalone instrument to get a better insight into data distribution or as a pre-processing step for other algorithms. Data objects of a cluster can be considered as one group. First, partition the information set into groups while doing cluster analysis. It is based on data similarities and then assigns the levels to the groups. Applications of cluster analysis in data mining. Data analysis, market research, pattern recognition, and image processing. It assists marketers to find different groups in their client base and based on the purchasing patterns, they can characterize their customer groups. It helps in allocating documents on the internet for data discovery. Used in tracking applications such as detection of credit card fraud. 5. In terms of biology, it can be used to determine plant and animal taxonomies, categorization of genes with the same functionalities and gain insight into structure inherent to populations. Requirements of clustering in data mining. 1. Scalability. Scalability, to increase style, in clustering implies that as we boost the amount of data objects, the time to perform clustering should approximately scale to the complexity order of the algorithm. If we raise the number of data objects 10-folds, then the time taken to cluster them should also approximately increase 10 times. It means there should be a linear relationship. If that is not the case, then there is some error with our implementation process. 2. Interpretability. The outcomes of clustering should be interpretable, comprehensible, and usable. 3. Discovery of clusters with attribute shape. The clustering algorithm should be able to find arbitrary shape clusters. They should not be limited to only distance measurements that tend to discover a spherical cluster of small sizes. 4. Ability to deal with different types of attributes. Algorithms should be capable of being applied to any data such as data based on intervals, numeric, binary data, and categorical data. 5. Ability to deal with noisy data. Databases contain data that is noisy, missing, or incorrect. Few algorithms are sensitive to such data and may result in poor quality clusters. 6. High dimensionality. The clustering tools should not only be able to handle high-dimensional data space but also the low-dimensional space. Association rule. Association rule learning is a type of unsupervised learning technique that checks for the dependency of one data item on another data item and maps accordingly so that it can be more profitable. It tries to find some interesting relations or associations among the variables of dataset. It is based on different rules to discover the interesting relations between variables in the database. The association rule learning is one of the very important concepts of machine learning, and it is employed in market basket analysis, web usage mining, continuous production, etc. Here market basket analysis is a technique used by the various big retailer to discover the associations between items. We can understand it by taking an example of a supermarket. As in a supermarket, all products that are purchased together are put together. For example, if a customer buys bread, he most likely can also buy butter, eggs, or milk, so these products are stored within a shelf or mostly nearby. Consider the below diagram. How does association rule learning work? Association rule learning works on the concept of if and else statement, such as if a then be. Here, if element is called antecedent, and then statement is called as consequent. These types of relationships where we can find out some association or relation between two items is known as single cardinality. It is all about creating rules, and if the number of items increases, then cardinality also increases accordingly. So, to measure the associations between thousands of data items, there are several metrics. They are support, confidence, lift. Support. Support is the frequency of A or how frequently an item appears in the dataset. It is defined as the fraction of the transaction T that contains the item set X. If there are X datasets, then for transactions T, it can be written as confidence. Confidence indicates how often the rule has been found to be true, or how often the items X and Y occur together in the dataset when the occurrence of X is already given. It is the ratio of the transaction that contains X and Y to the number of records that contain X. Lift. It is the strength of any rule, which can be defined as below formula. It is the ratio of the observed support measure and expected support if X and Y are independent of each other. It has three possible values. If lift equals 1, the probability of occurrence of antecedent and consequent is independent of each other. Lift 1, it determines the degree to which the two item sets are dependent to each other. Lift 1, it tells us that one item is a substitute for other items, which means one item has a negative effect on another. Association rule learning can be divided into three types of algorithms. A priori, ECLAT, FP growth algorithm, a priori algorithm. This algorithm uses frequent datasets to generate association rules. It is designed to work on the databases that contain transactions. This algorithm uses a breadth-first search and hash tree to calculate the item set efficiently. It is mainly used for market basket analysis and helps to understand the products that can be bought together. It can also be used in the healthcare field to find drug reactions for patients. ECLAT algorithm stands for Equivalence Class Transformation. This algorithm uses a depth-first search technique to find frequent item sets in a transaction database. It performs faster execution than a priori algorithm. FP growth algorithm. The FP growth algorithm stands for frequent pattern, and it is the improved version of the a priori algorithm. It represents the database in the form of a tree structure that is known as a frequent pattern or tree. The purpose of this frequent tree is to extract the most frequent patterns. Applications of association rule learning. Market basket analysis. This technique is commonly used by big retailers to determine the association between items. Medical diagnosis. It helps in identifying the probability of illness for a particular disease. Protein sequence. The association rules help in determining the synthesis of artificial proteins. Catalog design. Sequence discovery or sequential pattern in data mining. Sequential pattern mining, also known as GSP, generalized sequential pattern mining, is a technique used to identify patterns in sequential data. The goal of GSP mining is to discover patterns in data that occur over time, such as customer buying habits, website navigation patterns, or sensor data. Sequence. A sequence is formally defined as the ordered set of items S1, S2, S3, Sn. As the name suggests, it is the sequence of items occurring together. It can be considered as a transaction or purchased items together in a basket. Subsequence. The subset of the sequence is called a subsequence. Suppose A, B, G, Q, Y, E, C is a sequence. The subsequence of this can be A, B, C or Y, E. Observe that the subsequence is not necessarily consecutive items of the sequence. From the sequences of databases, subsequences are found from which the generalized sequence patterns are found at the end. Sequence pattern. A subsequence is called a pattern when it is found in multiple sequences. The goal of the GSP algorithm is to mine the sequence patterns from the large database. The database consists of the sequences. When a subsequence has a frequency equal to more than the support value. For example, the pattern A, B is a sequence pattern mined from sequences B, X, C, A, B, Q, and A, U, B. Uses of GSP, generalized sequence pattern mining. Market basket analysis. GSP mining can be used to analyze customer buying habits and identify products that are frequently purchased together. This can help businesses to optimize their product placement and marketing strategies. Fraud detection. GSP mining can be used to identify patterns of behavior that are indicative of fraud, such as unusual patterns of transactions or access to sensitive data. Website navigation. GSP mining can be used to analyze website navigation patterns, such as the sequence of pages visited by users, and identify areas of the website that are frequently accessed or ignored. Sensor data analysis. GSP mining can be used to analyze sensor data, such as data from IoT devices, and identify patterns in the data that are indicative of certain conditions or states. Social media analysis. GSP mining can be used to analyze social media data, such as posts and comments, and identify patterns in the data that indicate trends, sentiment, or other insights. Medical data analysis. GSP mining can be used to analyze medical data, such as patient records, and identify patterns in the data that are indicative of certain health conditions or trends.